All right, so I'll be running a simulation called conservation of mass, and I would like for you to watch the simulation and follow along with the notes. You're going to be collecting data. So let's begin. So you should have this open as you watch this video. So we're going to begin by going to the lab, and go ahead and pause the video and read this. So hopefully you paused the video and you read it. You're going to be writing about the scenario right here. So again, you can always rewind, read, and then summarize the scenario that you just read in here. Okay, so that's the first thing you need to do. Moving on, we're going to move on to, as you can see, the scenario, investigate and conclude and analyze. And your notes follow this. Okay, so this is the scenario, the investigate, and then conclude. Okay, and then the analyzing part is at the bottom. All right, so next. Again, go ahead and pause the video and read this part. Okay, so I assumed you have paused the video and you have read it. So pretty much the idea here is that we are going to launch a rocket, and that requires a chemical reaction, and we're going to be changing the amounts of the reactant, okay, and see if the reaction takes place. And the reaction that you're observing is hydrogen reacts with oxygen to generate water and lots of energy, and the energy is used to launch the rocket fuel. All right, so here's the procedure. I will follow this procedure, but go ahead and pause the video again and read. That way you understand what I'm doing. Okay, so the data that you're gonna be taking, by the way, before we begin to take the data, you go ahead and you write your predictions. So predict how the amounts of fuel available to the rocket will impact the altitude of the rocket, and explain your reasoning. In other words, how me changing here affect the height that the rocket will fly. Okay, that's the idea. All right, use the control slider to select the amount of fuel. This slider will change the amount of oxygen and hydrogen to keep the ratio. So I'm going to go ahead and change. Okay, so I changed. And then I'm going to go ahead and press launch. Okay, so things that you need to make sure that you have collected: the amount of oxygen, the amount of hydrogen, the amount of water, and how high you went. Okay. And the place where you collect this data is here: amount of oxygen, if there was any of those present as a product, water, and how high you went. Okay, so let's go back. Here's going to be your reactant, the amount of reactant. Here's going to be your amount of product, and here's going to be the altitude. Okay. And I should have launched the rocket with the lowest amount, so I made a mistake, but it's okay. It doesn't really matter. I'm just going to launch at this amount. Okay, so this is the amount of oxygen and hydrogen. I'm going to launch again. Okay, so it didn't even leave the ground. So here's how high it went. Here's the amount of reactant. Here's the amount of product. So this is a second trial. We have 3 trials, right? So the first one, the second one, and then we're going to go for the third one. So we tried here, so we're going to try the highest. right? Here is the amount of reactant, here is the amount of product, and here's how high the rocket went up. Okay, so this would be your third trial. And the nice thing about the video is that you can just stop and record the numbers and I can just keep going. Okay, so this is your first question. If you tested a rocket with 3 mixture of fuels, which that's what you did, with different masses of oxygen and hydrogen, what is the relationship between the masses of oxygen and hydrogen in each of the tests? So it's asking what's the ratio between the amount of oxygen to hydrogen. So look at those numbers and then answer it right here. Okay, so this is the place to answer. Let's go to the next question. Describe how the results you obtain demonstrate the law of conservation of mass. Use a mathematical equation that demonstrates how your data matches the law of conservation of mass. So this is the time for you to rewind the video, and I shown you the, let's see if I can go back to the scenario. I don't know if I can go back to, yeah, I can go back to the scenario. There we go. This is the mathematical equation. Okay, so let's go back to that conclude question. Describe how the results you obtain demonstrate the law of conservation of mass. Okay, so mass cannot be created or destroyed, it's only transformed. Okay, so the mass of oxygen and hydrogen is not being destroyed, it's just being, it's becoming water, right? That's what it is. And you're going to use the mathematical equation to explain that. And here is where you type the second answer. Okay, and then moving on. And you're welcome to, again, pause the video, look at this, and be able to answer the question or ask me questions. Okay, compare the amount of work done by the fuel, so how high the rocket launched, in each of the three trials. Explain why different amounts of reactants resulted in different amounts of energy of work or work. Okay, so again, answer this question right here. And by the way, the question is already here. And then next, use your understanding of the conservation of mass to complete the table. Use the table to answer the questions and explain your reasoning. How different ratios of fuel and oxygen affect the altitude of the rocket reaches, right? So how did the different ratios affect how high you went? Also, there's a place for you to complete the results. Okay? And whether or not mass was conserved in here. Again, I have the table in here. Okay, and you can type your answer right here. So you just fill in the table and whether or not mass was conserved. Okay, I'm going to give you a hint. If you notice, 16 plus 2 equals 18. So the mass in here became, all of it became water. Okay, so yes, mass was conserved. So you're going to do the same thing for the other ones. It's pretty much just putting them together and seeing whether mass was conserved or not. And I believe that's it. You don't have to do this last one. I believe this is the last question. That's the end of it. When you're done, you can just submit this on Schoology.